Assalamualaikum warahmatullahi wabarakatuh. My name is Mubarak Muhammad Bakri, and today I'm going to present about experiment 5, measure of jet forces. First of all, abstract. The purpose of the experiment was to determine the effect of the water jet with two different deflectors. The experiment was performed on different deflectors, which are hemisphere and plate. A set of weights were given to put on a loading weight to give forces. The lever mechanism needs to adjust after put some weight on it until achieve the stable position. Time measurement, flow rate, velocity and calculated force were obtained and compared experimentally for each deflector. During the experiment, there are mistakes and error of the machine which make the reading not accurate. Next is objective. The objective of the experiment is to investigate direction forces produced by the change in momentum of a fluid flow when a jet of water strikes a flat plate or curved surface, and to compare the result from this experiment with compute forces by applying the momentum equation. Next is introduction. Moving fluid in a natural or artificial system may exert forces on object with contact with it. To analyze fluid motion, a finite region of fluid is usually selected, and the gross effect of the flow, such as its forces or torque on an object, is determined by calculating the net mass that flow into and out of the controlled volume. These forces can be determined, as in solid mechanics, by using the Newton's second law or by the momentum equation. The force exerted by a jet of fluid on a flat or curved surface can be resolved by applying the momentum equation. The study of these forces is essential to the study of fluid mechanics and hydraulic machinery. Next is theory. A jet of fluid, when impinging upon a flat plate or a hemispherical surface, generate a force due to change of momentum of the fluid according to Newton's second law of motion. For example, when a velocity of water from jet nozzle with a diameter strikes on a flat plate or hemispherical surface, the rate of change of momentum produced and its magnitude is the same with the force exerted on the surface of the flat plate or hemispherical to support the water jet. The F generated by a jet of water when it strikes depend on the shape of the surface. Next is apparatus. We have used 11 apparatus for these experiments, which is weight position, deflector, nozzle, main switch box, flow control valve, volumetric measuring tank, sliding valve, water drain, water supply, tank, and level mechanism. Next is methodology. Step 1. Two different types of deflector, flat plate and hemispherical surface, were determined. Step 2. The cover was removed with level mechanism. Step 3. The test deflector was assembled. Step 4. The cover with assembled plate at the level mechanism back into tank was placed. Step 5. The 3 screws to cover were tightened. Step 6. Set the pointer to 0 by adjusting the screw level mechanism. When doing so, do not place any weight on the lever mechanism. Step 7. The sliding valve was closed. The flow rate of water was determined by recording the time required to fill up 3 liters volume of water in volumetric measuring tank. Step 8. Slowly open the flow control valve until maximum flow and put the desired weight on the level mechanism. Stop to put the weight until the pointer at level mechanism is at 0 notch. Step 9. The sliding valve was closed. Then the flow rate of water was determined by recording the time required to fill up the 3 liter volume of water in volumetric measuring time. Step 10. The sliding valve was opened, and step 8, and 9 were repeated by decreasing the desired weight on the lever mechanism until the flow control valve is at minimum opening. Step 11. The main switch and the pump were turned off. The sliding valve was open and the flow control valve was closed. And the last step, the weight on the lever mechanism was removed and the deflector was changed. Step 2 to 11 were repeated.
Assalamualaikum warahmatullahi wabarakatuh. My name is Mama Irfan bin Mokhtar and I'm going to be presenting about the results and the discussion. For the results, there are two tables, data for flat plate and hemispherical surface. In the data, we can see that we are given the FMEA, the measured force, in Newton, for both flat plate and the hemispherical surface. And then the volume of water collected are 2 for both cases, and the time. For the Q, which is the actual flow rate, we can get this by dividing the volume of water collected by the time in seconds. And then we do this for flat plate and the hemispherical surface. While for V, we use the equation 4Q over pi d squared, where our diameter is actually 0.01 meter. And the FTH, the theoretical force, for flat plate, it is equals to rho AV squared. And then for the percentage of relative error, in the equation, where the measured force minus by the theoretical force over the theoretical force times 100. And then for table 2, with the hemispherical surface, our theoretical force FTH is different, where we do the equation 2 rho AV squared. And then we do the same for percentage of relative error. For discussion part 1, we are asked to plot a graph of log FMEA versus log V for both the flat plate and the hemispherical surface on the same graph. As you can see, we did a scatter graph for both of the data, and we did a line of best fit for both flat plate and the hemispherical surface. As you can see in the graph, the blue line and the blue dots are for the flat plate, while the orange dot and the blue line and the orange line is for the hemispherical surface. For discussion part 1A, we are asked to estimate the slope of the graph for both the flat plate and the hemispherical surface and compare with the theoretical value as shown in equation 2 and equation 4 respectively, and comment on the difference. As you know, in the graph, the line of best fit is actually a linear graph, where the equation is y equals to mx plus c, and m is the slope of the graph. So for flat plate, we take a point from the line of best fit for flat plate, where we approximately, like for x1 and y1 is 0.65 and 0.2, where the other coordinate is x2 and y2 is equals to 0.86 and 0.56. So we use all these coordinates to put in the equation m equals to y2 minus y1 over x2 over x1. And then we ended up with the slope m, which is 0.70. And then we do the same thing for hemispherical surface, and we get that the slope m for hemispherical surface is 1.84. And we calculated the average theoretical force for both of the flat plate and the hemispherical surface. And for the flat plate, it is 2.374 Newton, while for hemispherical surface it is 4.456 Newton. And there is a difference between the value from the slope and the theoretical force for hemispherical plate and the flat plate. And this is because there's a difference in the force impact towards the plate surfaces due to different angles of the water impaction causing the value of the slope in the graph to be different than the theoretical value. For discussion part 1b, we are asked to estimate the y-intercept ratio of hemispherical surface to flat plate and compare with the theoretical ratio as deduced from equation 2 and equation 4 and comment on the difference. As you can see in the graph, the line of base fit is a linear graph, and we knew the slope of the graph, and the equation for linear graph is y equals to mx plus c, and we can just substitute the one of the coordinates and the slope of the graph to get the y-intercept, and from that we get that the y-intercept for flat graph is negative 0.9047, while the y-intercept for hemispherical plate is negative 0.686, and the y-intercept ratio is between hemispherical surface to flat plate. So the y-intercept of hemispherical surface is divided by the y-intercept of the flat plate, and the theoretical ratio is the value of theoretical force for hemispherical plate over the value of force for flat plate, and you can see that it is different, and this is because in real situations there will be minor and major losses of the fluid when going through the pipe and striking the plate. So there is a difference between the theory value and the measured value. For discussion part 1c, we are asked to compare the force exerted on the hemispherical surface with one of the flat plate and which one is greater. And from this experiment, we can say that the force exerted on hemispherical surface plate is higher than the flat surface plate, and it is due to the momentum produced, and it lies on the behavior of the water when it strikes the plate. So when it strikes the plate, it forms a radial sheet which impinges on the inner wall of the surrounding cylinder, and then divides some of the water flowing down the cylinder wall and the rest of the water flowing upwards. Although we cannot really see the spray when it is generated, it does seem that some water falls to the top side of the vane, and this would have the effect of producing a small momentum force in the downwards direction, so reducing the net upwards force on the vane. And from the equation, you can see that the equation F is equal to rho AV1 squared over rho AV2 squared cos theta. And for the flat plate, our theta is actually 90 degrees, which is equals to 0. And for the hemispherical surface, our theta is 0 degrees. So when it is substituted to the equation, it is equals to negative 1, and then it reacts with the negative, it becomes positive. And from the equation 2 and equation 4, you can see that F is rho AV1 squared for flat plate, and for hemispherical surface it is 2 rho AV1 squared. And you can see from the equation that the value of hemispherical surface, the force for hemispherical surface is actually greater than the flat plate. As you can see, it is 2 times greater. For discussion part 2, we are asked to compare the percentage of relative error for both the flat plate and the hemispherical surface as function of jet velocity. Comment on analysis and explain your reason. And based on our table, the percentage relative error for both the flat plate and the hemispherical surface are 20.08% and 2.13% respectively. And as you can see from the table, the percentage of relative error, it fluctuates. It tends to fluctuate, where it goes up and then it goes down, then it goes up, down, up and down. And this might come from a source of error. And this source of error might come from the shape of the plate, where the plate is not in a perfect shape, or in this case an incomplete sphere. And this is because our equation, it depends on the angle. With in the force equation, it depends on the angle, which is the impact of velocity from water to the surface of the plate. And the other source of error might be the spring coil, where the shape of the spring coil must be straight. If not, then the velocity which is applied by the water is inaccurate. For discussion part 3, we are asked to briefly discuss on factors contributing to errors or inaccuracy in experimental data and the possible recommendation for the existing results. For factors contributing to errors, there are two errors, which is parallax error and systematic error. For parallax error, it might be due to the position of the eyes, where it is not perpendicular to the scale of measurement and readings. And then for systematic error, which might be in case of error in the equipment. For example, the control valve may not be fully open, which will affect the result and causes the reading to be slightly off, or the spring that we use may lose its elasticity, and it can cause the reading to be all wrong, and maybe the errors in calculating due to the uncertainty in the measurement, as well as mistakes made during the results, during calculating the results. And or maybe the error during the preparation of the apparatus. Like for example, we make sure no weight is placed on the lever mechanism of the deflector when setting up the equipment. And the recommendations to improve the result, we can put the position of our eyes to be perpendicular to the calibration so that we can avoid parallax error. We make sure that our equipment is fully good, and like for example, we make sure that the control valve is fully open before adding the weights. We check the spring, we repeat the experiment at least 3 times and get the average value, and we use plates that have a perfect shape to increase the accuracy of forces exerted on the plate, and thus giving us more reliable data. For discussion part 4, we are asked to suggest 2 applications of jet impact in industry. For application number 1, the jet impact, it can be used to rotate the turbine, which is named pellet wheel in the generator. And the water jet, it applies force, tangential force to the wheel, and the tangential force of the water, it generates a moment or torque on the wheel to its maximum value. Therefore, it increases the mechanical energy of the pellet wheel, and rotational energy of the wheel is then converted into electrical energy. While the second one can be used as a water jet cutter, and water jet cutter is capable of slicing metals or other materials by using high pressure and velocity of water jet together with abrasive substance. And the process of water jet cutting is similar with water erosions found naturally, but it occurs with highly accelerated and concentrated. For the conclusion, the goal of this experiment is to compare the theoretical values of the force exerted by fluid jet impinging either a flat plate or a hemispherical surface. And as a result, we can deduce that the force exerted by the jet is directly proportional to the squared value of the squared velocity of water. And as a result, the force exerted on the hemispherical plate is greater than the force exerted on the flat plate. Due to the plate structure, the theoretical value for hemispherical is higher than the flat plate, as shown in the graph, and there is also disparity in terms of value, with the actual value and the theoretical value being different due to inaccuracies. And the cross-sectional area of the jet, it influences the velocity of the water because of the momentum, and the velocity will increase due to the wide construction of the plate.